Hi everyone. In this video we're going to begin to talk about chapter 4, which is called Gathering Data. What we'll talk about in this set of slides are the difference between experimental and observational studies, first what they are and then their differences, what are some good and bad ways to sample, and what are some good ways and bad ways to experiment. Okay? So first let's start off with the terms. What is an experimental study? Or rather, this is not a definition type of thing, but this is describing the process. A researcher conducts an experimental study by assigning subjects to certain experimental conditions and then observing outcomes on the response variables. Okay, and so some other definitions. A treatment is the experimental conditions that they're exposing the subjects to, okay, which correspond to assigned values of the explanatory variable. So remember, back in section 3, chapter 3, we're dealing with more than one variable at a time, and so we need explanatory and response variables. So that's a treatment. An observational study, which is different than experimental study, is when the researcher simply observes values of the response variable and the explanatory variables for the sampled subjects without anything being done to the subject. So in an experimental study, the researcher is sort of hands-on. They put the people into groups, they assign treatments, they control or they try to control for outside variables that happen. Okay, that's an experimental. In an observational study, the researcher simply observes what happens. Okay, so because that experimental study is much more is more contained, okay, than an observational study, it can lead to much stronger conclusions. Okay, because they can control for what we're going to call lurking variables and other things. So what that means is that in an experimental study, which are often about humans, but they can be about other things, the researcher will try to look at the whole picture, okay, or the everything that could possibly go into how the response behaves. Okay, for instance, if you can think of this in a drug trial environment. Okay, so the researcher puts you either into a what's called a placebo group or the treatment group. Okay, it will be as simple as possible. There are other more complicated things, but we have like one group that isn't really getting any medicine or whatever. Okay, and in another group you are getting that medicine. Doing so, and then you can assign people in certain ways to those groups to try to control for all possible varying factors. Okay, so for instance, if my groups, if I'm looking for treating, I don't know, sleep apnea, or I can't think of a good example right now, but treating, rather than me trying to stumble through an example, I could be treating something that doesn't have anything to do with a person's weight, okay? But weight could be what's called a lurking variable, in that it indirectly affects how the response is going to behave. The human body is an extremely tough thing to study and to control for all the different things that can happen, because there are so many different sort of side effects that we can't predict beforehand. You try to control for that in an experimental study, but in an observational study, you don't have any sort of control how it's made. You're just observing what's happening. Okay, so let's move on. When we look at a question, we have to realize or try to understand what kind of study is possible. So certainly an experimental study are preferable, okay, but they aren't always possible. They're the best that we can do, so to speak, but sometimes the best doesn't exist. So when does this not happen? Or when does this happen where we can't do an experimental study? So there may be ethical reasons in which you can't do a proper experimental study. So for instance, you shouldn't expose subjects to certain treatments. In a cancer trial, okay, in a trial for a drug that maybe treats cancer, and you bring people in for sort of an experimental study, there's often a group that gets sort of nothing of substance, okay, whereas the other group gets this new experimental drug. Certainly, that wouldn't be ethical to give people with a certain type of cancer no treatment at all. So, an experiment may still be possible, but not in sort of its purest form. Okay, so for instance, in that example that I just gave, you would certainly give the people who aren't getting the new experimental drug the sort of standard of care that's out there, okay, instead of giving them nothing. Another reason that experimental studies may not be possible is that it's hard to control if the subjects will follow directions. So if all of your research is not done in a totally controlled environment where you can control how the subjects will follow directions, that's sort of risky because if they're sent home and told to take the drug or do whatever, they may not take it. And so that's certainly going to skew your results. And it's much harder to get subjects to participate in experimental studies. Okay, an observational study where you just see how things observe, that's easy to get data for and get subjects to participate because you may not even have to ask their permission to take down whatever you see. Okay? Whereas in an experimental study, participation can be quite intense. Okay, it can be intense on the person depending on what the experiment is, and so they may not be willing to participate. When you can't perform an experiment, you may just take a survey. You can collect data that's already been taken, okay, so you can take it from somewhere else, so on and so forth, and still answer your question. Okay? So I may not be able to take new data on this new thing that I think is effective wherever, but there may be studies that have been done previously that already have data that can still inform my decision. So let's talk about good and bad ways to sample. Okay? Certainly, the question that I ask in the first step of the statistical process is about the population, is about some population. Okay, so for a drug, is the coronavirus vaccine going to be effective for in the whole population? Okay, all my questions are about the population, but of course I don't have enough resources to collect everything, so I need to take a sample. Okay, and so important terms when I'm talking about sampling first is a sampling frame. Okay? And it's a list of subjects in the population from which the sample is taken. So, for instance, if I am interested in collecting data about Shippensburg University, I can get a list from the registrar of all students on campus, okay, or currently active at the university. Okay, so that wouldn't be bad for me to get. And so that would be my full sampling frame, which is an ideal case. But unfortunately, a sampling frame may not be available. Okay, so that's a sampling frame. Good ways to sample are this. So the first and best way is called simple random sampling. But there are two others that we'll talk about: cluster random sampling and stratified random sampling. So those are the good ways, and we'll define each of them in turn here. Bad ways to sample is a convenience sample of some sort, okay, or a volunteer sample. So we'll talk about those as well. The simple random sample is the best that we can do in some sense. Okay, so a simple random sample is this. I select n subjects from the population, meaning that sample frame, and I collect them from the population at random, such that each person in the population has an equal chance of being picked. Okay, so if my population contains 5,000, okay, then each person will theoretically have a chance of 1 in 5,000 to be picked. So there are many ways to carry out random sampling in statistical software. Okay, so that's sort of the standard that we like to have is the simple random sample. It turns out that it's not hard to implement. But that's if I have the full sampling frame, okay, and sort of everything is perfect. Then I do simple random sampling. In some cases, defining a sampling frame may not be feasible, but it may be possible to identify clusters of subjects. So, what does that mean? Or what does that lead to? That leads to cluster random sampling. So, what cluster random sampling does is it divides the population into a number of clusters. So, maybe for instance, I'm interested in getting data from New York City. Okay? I certainly can't write down all of the people who actually live in New York City. I could look at a phone book, if those even exist anymore, to get a lot of the people, but it's not going to include all of them. So if they don't have a phone or something, then they're not going to be in there. But I can split up the city in, so like city blocks, and then go to them and get my data somehow. So how do we get that data? Well, we define those clusters, and then we select a simple random sample of the clusters and survey all subjects inside that cluster or block. Okay, so for instance, if I was interested in something about New York City, okay, I divide the city up into blocks, okay, and then I select a simple random sample of the blocks. So I select, I don't know, the 1st, the 4th, and the 20th block, okay. I select those, and then I go to those blocks and I try to survey every single person in that city block. Okay, again, maybe not an easy task if the block is a full city block, but still doable. So what are the advantages of cluster random sampling? Well, the first advantage is you don't need a reliable sampling frame. Okay, since I'm dividing the population into clusters, and then sampling everything from the cluster, I don't need to know what the whole population is. Okay? And cluster random sampling is a good option when simple random sampling is excessive for some reason. Okay? Disadvantages are it usually requires a larger sample size for the same precision. Basically, cluster random sampling is not as good. Okay, and so when you have a sort of a lesser sampling method, okay, the data that you're getting in is not as good. You're going to need more data or more people than you usually would to get some sort of answer out. Okay, and another disadvantage is when you select a small number of blocks. Okay, that's going to result in a more homogeneous sample than in the population. Okay? So, for instance, in that city block example, if I'm interested in the everyone in the city's opinion about something, but I only randomly sample 3 blocks, okay, it's very likely that the people in those blocks are going to have similar opinions about this. But if I only sample 3 blocks and they turn out to be from all one neighborhood, then that's not getting the full, that's likely not going to represent the whole city's opinions, because especially in somewhere like New York City, there's a lot of people, and different neighborhoods probably vary differently on how they view some subject. Okay, so you're taking a more of a chance when you use cluster random sampling of not getting a good sample, but it's not a bad solution when traditional methods aren't available or aren't needed. Okay. The next one we'll call stratified random sampling. Okay. In some cases, it may be beneficial to view the data in different groups or strata. This is different than cluster random sampling. So, in stratified random sampling, we divide the population into separate groups called strata based on some attribute or characteristic about the subject. Okay? And then we select a simple random sample from each strata or stratum. Okay? The advantage of using stratified random sampling is that we want to make sure that we include enough subjects from each group in our sample. Okay? And the disadvantage is you must have a sampling frame and know which strata each subject belongs to. So we went from cluster random sampling, which is sort of the dirtier way of doing things when you don't have means to do simple random sampling. But now, stratified random sampling is sort of a more challenging sampling scheme where you do have to have a sampling frame. You have to know the people in your population. And more than that, you need to know what strata or group they belong to. Okay? And you do this because you want to make sure that you have sort of equal representation from each strata or group. So here's an example with Shippensburg. Okay, so the student population of Shippensburg for each group. So if I were able to get a list of all students from the registrar who are active now, okay, and I just randomly sampled with the probability that each person gets sampled is the same. Okay, so I just pick out some 5 random people as my sample. That is called simple random sampling. Okay. Cluster random sampling will happen, say, maybe if you go and ask the registrar for that list of students or that sampling frame, and they say, no, you can't get that, then I don't have a reliable sampling frame. So what I can do is go around to random classrooms. Okay, so I pick a time in which most people are in class. Okay, and so I get a list of all the classrooms that are in use at a specific time. Okay, and so those are my blocks or clusters. And then I go to each classroom. Okay, I pick out random classrooms. Okay, so I select a random sample of classrooms, and I go to them and I ask each person inside the classroom. Okay, so that is cluster random sampling. So I'd randomly pick the classrooms to go to, but I'd select everyone in that classroom. Stratified random sampling would be when I have that list of students. Okay, I have the list of all the students, and I have their year. Okay, so in simple random sampling, I don't care about the year. I just randomly select the students. But if I'm to make sure that each year has sort of a equal representation, then what I could do is I could split you up into a year, first, second, third, fourth, 4 plus, okay, after 4, and I could select maybe like 5, randomly select 5 from each group. That would be stratified random sampling. So here's a visualization of each of them. So in the first picture, the top picture, the stars represent people, and then the X's represent that random sample of those people. So I have all the people, and I randomly sample from around them. Okay. Now, in stratified random sampling, I have all of the people, okay, and I split them up. Maybe this is like a high school. I split them up into freshmen, sophomore, juniors, and seniors, and I randomly sample from each strata. Okay, so in each case, I'm randomly selecting 12 people. Okay, so in the first case, in the random sampling case, I just randomly selected 12 people from all people in the population. In stratified random sampling, I split you up into freshman, sophomore, junior, and senior. Okay, and I selected 3 from each group randomly. So I performed random sampling inside each strata, and so I still have my 12 people, but they came from a different way. And then in cluster random sampling, maybe all of the people were at lunch sitting at tables of 4. Okay, so I randomly selected 3 tables and interviewed all 4 of the people at those tables. So I got 12 observations, all in 3 different ways. Okay, but we got the same number of people, but the way we got them was different. So here's your turn. I'm interested in finding some information about the residents of New York. Okay, and I give you 3 situations. You tell me what they are. Okay, and so I probably actually answered this if you were listening to the video, but if not, it shouldn't be too hard.